Okay, in order to prepare our fonts first, let's go to the top of our QuadBatch class, and just above it, we'll set up some enumerations for different types of alignment, for how we want to align our text on the screen, left align, right align, and center align. And the way we're going to process our fonts is going to be with a specified key color, and we're going to use green, as in 0, 255, 0. R0, green, 255, blue, 0. I'll just add a comment here. Okay, and we have to make sure that our fonts are in alignment. A good piece of software for making fonts would be, for example, something like SPRITE-FONT2, where you can pick your font, change your default font size, you can change pen or brush settings, drop shadow effects. For example, if you wanted it to glow, maybe red, enable effect, or you wanted to give it a bevel, say curved in, enable the effect. And you can play around with these settings, see what you get, even emboss it, drop shadow, change the direction of the light, depth, opacity, or how non-transparent it is. And when you're done, you can export it and pick the color that you want to use. We'll take the spacing down to 1, and I'm going to change this manually to 0, 255, 0. Okay, and click export. That reminds me, I'll have to run the program as administrator. Right click it, run as administrator, and then it should allow you to save it, because it's trying to save it into program files because it's an older piece of software, and that's before that became not allowed. So here's another example of a completed font. You'll notice that they're 16 in width, and then it wraps back to here, and that they're all exactly the same height. That's actually going to be important. Exact same width is not as important though. As you can see here, this is not horizontally uniformal. The green pixels help to determine when it's starting a new character as it scans through the map. This white here isn't actually white, it's just showing through because it's a white background. These are actually transparent pixels. So you'll want to store that font texture into your content folder as such. Double click on content. Because QuadBatch is going to expect it, we'll have to add it to this project even though we might not use it. So I'll just copy the file into here, and I'll be back in a second. After you've copied the file into your content folder, you can select it and then build, and yes, you'll save the project. Okay, in preparation of the font, we're going to need a structure which will hold information about each character in the font. So like top left, bottom right, that character's width, its height, half the width. We'll just scroll down into the global variables here, and we'll add font data as private. FD, and we'll go down into our constructor, and right around here, we'll allocate memory for our font data, 430 characters, although we're probably only using 128. So here you could set your default font depth, since it'll be 0 anyway when it constructs this, because this is C#, and that's what C# does, then we don't have to include that. So after we've set up the two-dimensional camera, we can call prepare font and pass in the texture for the font. Now it doesn't know what we're talking about yet, so let's go down to prepare font. Now, I wouldn't normally do this, but this is something that's only going to be used with prepare font, but we may need access to it in other places, so we'll classify it as a private global near the prepare font section. We may need to request what is the average width, in which case we'll use a getter and return average width. Oops, I call this average, it should be average width. So that way average width is kind of locked away and you don't see it, but if you did need to get the average width, you can. So as I was saying, this will take the texture for the font. So I paused it and I typed this out. If the font is null, then we write a warning and then we return. And we're going to need a list of colors that make up pixels comprising the font. So the font color data. Font texture is equal to the new font text that was passed in. So the next thing we need to do is break apart our font and sort through it to figure out where the characters are. So we got to locate some memory for font color data as colors. Will be the font texture width times the font texture height. Now we need to get that data. Font color data. We don't have to worry about performance here because this is just a preparation method for mapping out how to use the texture font. So we're going to say the font texture was loaded and set an integer for width, font texture's width, and one for height. High is the font texture height and default font height. So we're going to get a color and take a look at it first. Set W and H to be 1 unit, which will represent how far in the UV space it increments as it checks. And the UV space operates on a 0 to 1 basis. So we got to break that 1 up into this many units wide and this many units high. Starting at I equals 32, being the character we want to start with. So the starting X and Y position is going to be 0, 2. It's the first place we're going to look at. Go down as false and finished. false. So this is for when we complete a line, and this is for when we're done. So as I was saying, in fact, I could have done this down here. Color is equal to color font color data, starting at the very beginning. So first we're just going to get the color of the very first pixel. Set average width to be 1f for now. Done is false. And this is sort of a preliminary check. So it'll go down to 3 horizontally, so 3 pixels to the right, plus the size of a line horizontally, which is wide, but then we have to multiply it by how many lines we've gone down. Yeah, times wide. Then we got to check the color, and if the red's less than 5, some of these don't come through 100% perfect, so we're just going to make sure the color is very close to what we're looking for. So if the green is greater than 249, and the blue is less than 5, and the alpha is greater than 249, meaning it's opaque, not transparent, and done is true. So we found our first solid color. And the reason why we start YA at 2 down, because the very top line is going to be green already. We want to find the second line from the very top. So we want to find out how far down it goes before it hits a green line. And that's how it knows how high the fonts are going to be. If YA is equal to height of the entire texture map minus 1, done is true, and we'll write a warning because that shouldn't happen. Error finding font height. And while not done, it just continues to loop. Now wherever YA stopped, that should tell us approximately what the height would be. So the font height would actually be YA minus 2. Now we're going to set the Y position to 4 so that we know that we're at least partway down into the first character, so we can check for horizontal green lines. Finished is false. Oops, this should be do while. I suppose I could have used done here also. Color is equal to the font color data. So we're going to get the next color to look at. Horizontal position plus vertical position. Multiply it by the width in order to get how many pixels in we're looking at in this list because it's linear. If the color is within the ballpark figure. Oops, I had a couple of bugs here. Earlier I had a few bugs up here. This should have been a comma. This should have been a do. There should have been a semicolon here. We're going to be using finished for an outside loop boolean, and we're going to reuse done as an inside loop after, so that's why we have these two different booleans. We're going to be starting off with the index for the font data at 32. We're probably not going to use anything under 32 anyway, so we're going to skip everything up till 32. Okay, so our XA variable is 0, and our YA variable is 4. So we're on the very left side where the green line should be, and we're 4 pixels down when we start this loop. The very first thing we're going to do is check to see if we actually are in a green vertical line. And since initially we should be in a green pixel, it'll move XA forward, and the next pass of the loop it'll have to be an else because that'll be most likely a transparent pixel. So now we have the first transparent pixel of the first character. We can record that font data at the index that we set to 32, being our starting index, which would be a space character. So its left hand side would be, instead of saying XA and YA, I'm going to say X. It'll be X plus 1. We can also set the Y1 to be YA minus 2. I'm saying minus 2 instead of minus 3 because as you can see here it's at 4, just to give it 1 extra pixel space of padding, just to be safe. And done is false initially, and then we do an internal loop to see if it is in fact going to be false. Well, not done. And what we're doing here in this loop is we're scanning horizontally again to see when we hit a green pixel, and then we know that we're at the right hand side of that font. So what's the color? The current pixel location, X comma Y, same thing. If the color red is less than 5, same idea. So let's just copy this here. Oops. So it's probably a green solid pixel. We can say done is true. Suppose I don't need these brackets. If XA is greater than or equal to the width of the texture, then we also know done is true, and it's time to go down to the next row. Oops. So we signal for it to go down to the next row. And since we got the left hand and right hand side information, we've already recorded the left hand side. So let's now record the right hand side, because we've reached the right hand side now that we hit done. It'll be XA minus 2, giving it 1 pixel space from the green line. And Y2 we'll say is, let's going to be YA minus 4 to go 4 pixels back up, because as you remember, we put it 4 pixels down into each row of fonts as we scan horizontally to check so that we're not in a green line. So we subtract 4 to get the top of that little green box, and we add the font height where the bottom would be. And now Y2 has the bottom of the little green box for the font. Technically, it's 1 pixel up from the bottom. So now that we have the left and right side, we can calculate the width. We'll pre-calculate that for greater efficiency. Okay, let's just copy this to set the height. The height of this font character is obviously going to be Y2 minus Y1. And we'll add up the running total of the widths so that later we can divide by the number of characters to get the average width. Average width is used for less specific font processing so that you can draw the fonts just a little bit quicker. I'll get into that later. So the font's IW, the intermediate or the middle of the font. IW is basically just half the font width. If I is less than 130, then I++. But if for some reason it kept going, which it shouldn't be possible, it could be something wrong with our texture map or maybe even our code. Again, you probably don't need these brackets. Anyway, if XA is greater than or equal to the width of the texture, or we're going down. Now, it should have triggered go down already, but if it didn't, we got this in here to be safe. Like, for example, if there's no green border on the right-hand side for some reason, go down is reset to false, and XA is going to be 1, so we're 1 pixel ahead of the very left side, 1 pixel to the right of the green line, and the Y position we set to the current YA plus the font height, so we're going down by the height of a font character. And I say +2, and I say +2 because the font height doesn't count the 2 green lines. So we have to add 2 to account for those 2 green lines that we're not considering, the top green line and the bottom one. So if YA greater than or equal to the height of the texture map, then we know we're finished, so we'll signal that we're done. And if I for some reason is greater than 127, finished is true. And that could very well happen. There could be 129 characters or something in there. This is for while not finished. Text horizontal spacing is going to be the spacebar characters right-hand side minus the spacebar characters left-hand side. I suppose we could have just said .w times the default font size. This should be text, not text. When the screen size changes, you can set the default font size so that it's appropriate for that screen resolution. You can also change it at any time you like when you're doing your drawing so that you don't have to specify it in the function call. You just change it once and then leave it for a while and then change it again when you need to. But in your method, you have the option of specifying a font size. What that's going to do is it's going to rescale the already scaled font size. So we'll do the same thing here, Y1, except we're going to say -2 default font size. So we're just spacing vertically a little less than we are horizontally. That's why there's this -2 here. The average width is going to be the average width because this is a sum that we were totaling up right here, and it's going to be divided by the current index, which would be the last index that we check, and we got it times by 1.2 because our index skipped the first 32 characters. There's technically 32 less than I, so that just kind of helps to boost the spacing a bit. Suppose you could go I minus 32 here. That should be fine. And you can tweak this depending on how you want your spacing. Don't forget to put the F after here, otherwise it thinks this is a double. Okay, and that's it for preparing the fonts. Let's make a quick and easy way to change our default font size without messing up other parameters. First of all, we'll just do a simple get, and we'll create a set. Default font size is equal to value, and let's just go like this so it's not quite as confusing. And also we have to set the text horizontal spacing. Let's just copy it out of here. That would actually be the vertical spacing because we've got the -2 here. So the horizontal, we'll just copy from here, paste it in. There you go. Default font size. Everything checks out. There shouldn't be any errors. So I'll just do this unspeakable act of compacting everything a bit because we're not going to work with that again. We already know what it does. We're going to need something for being able to measure strings so we can align them correctly, and something for drawing the strings. So to measure one of our strings, we say public vector2, which will return a vector2, which will return the vector2 of our measured string. So that would be the height and the width. we'll say the kerning space is going to be the texture's horizontal space times 0.25 f, so it'll be about a quarter of the regular horizontal spacing. Our multiplier is going to be our default font size divided by 2, and the size vector will be set to, initially, it would be 1, fd 32h, so the height of the first character times default size. So we've already set the parameter for the height. Then we have to go through our list of characters and figure out how wide the string is going to be, while we're less than the text length. Don't forget your a++ or you'll have an infinite loop. So we're going to add to size.x. Text a will contain a character in a string, which can also represent the index, whether it's 32 or higher, because the integer version of that character would be the ASCII number. So we add the width of each character to x, and then we say the size.x times equals our multiplier. So we got to take the scaling into account, and we got to add in all the little spaces between each character. Pardon me, this should be .x plus equals. So the spacing between the characters is added in, and we return the size. Now if we just want a fast, close approximation of the size of the string, so if we're doing this very frequently, we can do a simpler version. We'll call it measure string fast, taking string text. Just copy this and paste it down here, and put return size on the bottom here so it's not complaining. Now, a quick and easy way to get the x, or the width of the string, is to say the text length times the average width. This is why we were calculating that average width before, so we could take advantage of it for stuff like this. And we scale it based on the default font size, and we add in our kerning space, text horizontal spacing times a quarter. So we'll add those little spaces in. Oh, I forgot the .x again. This is .x. Okay, that's the quick way of doing it. Not 100% accurate unless it's uniformal fonts, but it's close enough for pretty much any font you're going to use, and for pretty much any scenario. There may be also a scenario where you want to measure multiple strings, like if there's carriage returns. Let's just do that real quick. So public vector 2, measure multi-string text. The purpose of this sort of thing is so that you can kind of get a general idea of how big of a box you need to contain all your characters. So if you have multiple sentences on different lines, this sort of thing comes in handy. We need to know the rightmost character. We need to know the bottommost, current space again, which was the text horizontal space divided by 4, and we'll be getting the width and height as we go. Start off with a equals 0 and index 0, and we'll loop while a is less than the text length. So have a character for the letter, and the index of it is going to be integer of that character. So if the character itself is a carriage return, then we set the px to be 0, and our py has the vertical spacing added to it. So we've moved the coordinates to account for the carriage return. We increment a before we go to continue,